and factorial is going to return a bint, and I'm going to have to new up a bint down here in order to make that code compile, and bint expects a string as a parameter, and I'm going to need one more of those. There we go. And let's see. Oh, now I've left off my parentheses here. Are you happy now? What happened? Because I did this rename, this expression over here failed. And, oh, helps if you spell it out, idiot. There we go. Now we're happy. Java, Scala, hello world. And there we go. Factorial 12 is some really large number. Okay? So again, imports are now scoped, as I said, by the curly braces. So that includes that import alias that I did up there as well. Okay? Again, the fact that I can effectively rename classes at the point of use makes the language more accessible to people who want to try to build DSLs inside of the Scala language. Okay? Let us continue. If we look at this particular expression, right, 1 plus 2 plus 3 divided by x, where a Java programmer might see those as operators, the Scala programmer will see those as method calls. Because that's effectively what they are. They're method calls. Now, they're method calls that are going to be highly optimized. The Scala compiler is going to look at those expressions. So if we go back to my code here, and if I say I want to print out system.out.println 1 plus 2 equals, as I said earlier, the Scala compiler is not going to generate, it's not going to create a new object of int type and then create another new object of int type and assign the first one to be the value 1 and the second one to be the value 2 and then invoke the plus method on that int type. Scala compiler is much smarter than that. It's actually going to recognize that these are two constant values, and it'll actually fold those two together and turn this into the constant value 3 during the compilation phase. Okay, so it's going to recognize when it's doing optimizable environment. But what this means now is that if I choose to create my own class, I'll call it really big integer, that supports numbers even larger than what big integer can support. I don't know what those numbers would be. But if I choose to create a new mathematical type, I can define those same operations on that type just as the language itself does. And so again, we create consistency in the language where Java right now has artificially created difference. Okay? So if I chose to, I could define like so. If LHS is less than RHS, return 1, else if LHS equals RHS, return 0. Whoops, this should be -1. The traditional comparable syntax, else return 1. If the left-hand side is less than the right-hand side, return -0 or 1 for less than, equal to, or greater than accordingly. The Scala compiler, he's happy with this. He's okay with this. We can define our own operators inside of this world. And so if I choose 1 less than, equal to, greater than 2 equals okay. Now what's it complaining about? In this particular case, because it's an infix operation, like so, it's assuming that it's a member of int. All right? Which it's not, and I can't introduce that. Okay, Scala is not the same thing as Ruby, But if I do, and in this case, it's going to be awkward to do, but it would look something like this. Okay? Again, I don't want to go through the hassle of creating my really big int class just so I can show you this operation. But the definition of this operator, as far as Scala is concerned, is just a method with a funny looking name. So let me get this to compile real quick and I'll show you what it looks like. Okay, Java P, hello world. Notice second line up from the bottom. Public static final int, $less, $eq, $eq, $greater, parens, int, comma, int. Okay? Scala is basically going to make up a name that makes sense based on the individual characters that are there. And if you wanted to call that method from Java, you would have to type $less, $equal, $greater. So rule number one about using Scala is if you still have developers on your team who are using Java, don't punish them like this. Okay? Write methods that are going to be easily accessible from Java. This is why I'm doing exactly this and showing you some of the bytecode disassembler if you've not seen it before, so that you can do the same thing for your code when you start using Scala. All right. Next, functions are objects. And so if they're objects, we can A, refer to them as parameter types, and B, pass them around. So in this particular case, what I've got is a situation where once per second I want to do something, right? In this particular case, once per second I want to print something to the console. So again, we come back here to the editor, and I'm going to define this method def once per second. And in this particular case, I'm going to start from simple, right? I'm going to say while true, let's see, system.out.println ping, and then I'm going to sleep for a second. Thread sleep 1000. Okay? Now, first of all, those of you who've called thread.sleep, what am I deliberately leaving out here? Exception handling, right? Because thread.sleep is documented as throwing, what is it? Illegal programmer exception or something like that, right? There's basically the exception, right? That says, you know, what happens if somebody calls, you know, interrupt in the middle of this sleep in order to wake this thread back up, in order to break deadlock, blah, blah, blah. And that's a checked exception according to the Java language, right? Well, it turns out what a lot of Java programmers didn't realize is that checked exceptions are purely part of the Java compiler. The Java runtime doesn't care whether you're catching a checked exception or an unchecked exception. It makes no difference whatsoever. And so different languages that map to the JVM can decide how to deal with this exception problem. And the Scala compiler says, yeah, there's no such thing as checked exceptions. They're all fundamentally unchecked exceptions. Okay? So we come down here and we call once per second, like so. Okay? And let's make sure it all compiles and runs. Let's see. Once per second of type unit does not take parameters. Huh? First of all, this notion of the type unit. Unit in a functional language effectively replaces the idea of void. Because in a functional language, which is based on the principles of mathematics, there really is no notion of having no type, right? A function in math takes a parameter and returns a value, or takes several parameters and returns a value. So the idea of having nothing, void, doesn't seem to make sense. But practical reality says that if we're going to interact on top of the JVM or on top of some other platform, there are going to be cases where I don't want to yield a particular value, where I don't have a value to return, period. And so we create the notion of this type called unit. And the only value of unit is the value parens. Okay? Kind of like Boolean has two potential values, true and false. Parens is the one value of unit. And unit is the type which represents no type. So to be very blunt about it, when you think about unit, you can think about it as being null and void both.